In this video, I'm going to talk about IUPAC naming, and this is going to be the first part of this video. And to be specific, we'll be naming hydrocarbon or true. If this is your first time coming across our video or visiting our YouTube channel, don't forget to like, share, and subscribe. Now let's check the first case that we have here. We are given a compound and we are asked to name this compound. First of all, you check everything that you are seeing here. All the bond between the carbon to carbon atom is single, right? That makes this compound to belong to alkene family, right? Because it is a saturated hydrocarbon. Now, the second thing that you're going to consider is to check the number of carbon atom that we have. Now, if you look at this, we're having 1, 2, 3, 3 carbon atom, right? And don't forget, according to homologous series, whenever we have organic compound with three carbon atom, that basically means it is group, right? Now, and since everything is made up of single bond or true, no double bond or triple bond, this is going to be propane. That's going to be the first name. Now let's check another case that we have. Suppose we are given another compound CH3. See, we are having H3 here. Then we are having hydrogen here, right? Then we are having CH here. Then followed by, this is double bond CH2. Now let's say this is another case that we're having here, and we are asked to name this compound as well. You don't need to stress yourself. What you need to take note of is check the presence of what? Of bond. If the bond is what? A single bond or true, that basically means it is alkene family. If it is double bond, that basically means it was alkene. And if it is triple bond, that basically means it's what? It is alkyne, right? Then the next thing, you check what? The position of the double bond. Check if there is presence of position, like the position of what? Of the bond, right? If there is presence of double bond or triple bond, check their position. Then the next one, you check for attachment, or you call it substituent or attachment. You check for the words for the substituent or attachment, and at the same time you check for the words for the position of that as well. It's very important. So bond, you check for bond, position, substituent, then position. Now first thing, we have to check for what? For the bond, right? And we can see that we actually have what? We actually have double bond here, right? So what I'm going to do is that according to normal rules, you check the longest carbon to carbon atom, carbon to carbon chain. And if we look at this, we're having 1, 2, 3, 4, right? That's the longest. 1, 2, 3, 4. That's also the longest. So that's that whichever way we count, the highest carbon to carbon long chain here is actually what? 4. So I'm going to start numbering from this side because it's carried a double bond. 1, 2, 3, 4. If I number like this, and that's basically backward, and if I number forward 1, 2, 3, 4, it basically means if I'm going to consider backward here, I'm having 1, 2, 3, 4, right? That's that the double bond is on position 4. And if I'm considering the forward numbering, that's that the double bond is on position carbon number 1, right? Between 1 and 2, and this is between 3 and 4. But having 4 carbon atom, that's going to be boot, right? 4 carbon atom is what? Is basically boot, right? And if you look at this very well, the double bond is on position number 1. We're going to have boot 1 in. That's basically what we're going to have. Then at the same time, substituent. Do you have substituent here? Yes, on carbon number 3, because I choose to follow this side, right? Since I'm following this side, right, of numbering, then that simply means I'm going to pick the attachment at position number 3 and not 2, right? If I'm considering this side, that's basically when I'm going to go for 2 and not 3. So from here, we're going to have this way: theory methyl, right, boot 1 in. That's basically the name. Now, this compound very well. First thing we need to take note is actually the number of carbon atom. Let's check for the longest carbon chain. Here, if I start counting from here, I'm going to have 1, 2, 3, 4, 5. So the longest carbon chain here is actually 5, right? Because whichever way I try to count, the longest is actually 5, because we start from here 1, 2, 3, 4. This is basically 4, right? And this 1, 2, 3, 4, 5. So I'm going to follow this side. So let's number forward and backward. We're going to have 1, 2, 3, 4, and 5, right? Then backward 1, 2, 3, 4, and 5. And again, what do I tell you guys to check. Always check for what? For the bond, right? Check the bond if there is double bond, right, or triple bond. Then at the same time, you look for the position. It's very, very important. Then followed by the substituent, and also what? Position. And when it comes to the position, you always consider the smallest possible position that we have, the smallest one. That's what you're going to consider. Now let's go ahead and name this one. You are having 1, 2, 3, 4, 5, right? 5 carbon atom simply means you are the compound is actually pent, right? That is pent, right? It's 5. And the reason I'm writing pent is because I can see that there is double bond here on position 2 and 3 if I'm numbering forward, but if I'm numbering backward, it's on position 3 and 4, right? And I know that 2 and 3 is kind of what of somehow small compared to what 3 and 4, right? So here I'm going to pick the lowest, which is actually 2, right? And then here I'll go for the lowest, which is what 3. So since numbering forward actually confer a lower position to the double bond, then I'm going to prefer numbering forward. That is forward like this from 1, 2, 3, 4, 5. So this is going to be pent. On position 2, we have double bond. We are going to have 2 in. That's what we're going to have, pent 2 in. Now look at this. Since I'm numbering like forward, I'm going to on position 2, on carbon number 2, you see we have an attachment here. This should be CH3, right? So we have an attachment here, and at the same time on carbon number 3, we have an attachment. So that's going to be 2, 3, right? Then dimethyl pentyl. Let me write it here. 2, 3, right? Dimethyl. And I'm using the word di. That's because we're having 2 methyl group that is used as a substituent here. 2, 3 dimethyl pent 2 in. That's basically the name. Now let's go ahead and name another compound. Now let's look at this question that we have here, right? If you look at this, we don't have any double bond, we don't have any triple bond. Everything is single bond or true. Then we just have to check the like the highest number of carbon atom. That is the basically the longest carbon chain. So counting from this side 1, 2, 3, 4, or counting from this side 1, 2, 3, 4, it shows us at position 3 we are having a methyl group, right? So if I number forward, like look at this 1, 2, 3, and 4, right? And by number like this 1, 2, 3, and 4, right? As you can see here, whichever way I numbered, I try to number. If I number like this 1, 2, 3, and 4, right? Or I number like this 1, 2, 3, and 4, whichever way, attachment is on carbon number 3, right? And then what happened is that if I'm considering what the backward numbering, I'm going to have the attachment on what on position 2, right? And if I'm considering what the forward numbering, I'm going to have the attachment on what on position 3. So since 2 is kind of lower than 3, I'm going to pick 2. So in that case, I'm going to have this name to be 2-methyl. Since I'm having 4 carbon atom, that is basically butane. Butane in the sense that everything is single bond or true. So that's basically 2-methyl butane. So let's go ahead and name another compound. Name this compound. Now, as you can see, we have a substituent here, and we have 2 substituents. We have the chlorine, and we have at the same time we have the methyl group. Now let's consider the longest carbon atom here, longest carbon chain rather. So if I number like this, I'm going to have 1, 2, 3, and 4. And if I number backward, I'm going to have 1, 2, 3, and 4, right? So if you look at this very well, if I still consider this other side, I'm going to have 1, 2, 3, 4, right? So whichever way I try to number, the longest carbon atom is actually carbon chain is actually 4. So since it is 4, I'm going to have the name to be, that's going to be butane, right? That's butane. And the reason why it's butane is because there's single bond between the carbon to carbon atom. So I'm having butane. Then if we now consider numbering from this side to this side, on position 2, I'm having what? Methyl group, and on position 2, on carbon number 2 here, we're having what? A chlorine group, right? That's halogen group. So this is basically the backward. Consider like numbering backward, that's actually what I'm going to consider. That is, I'm going to follow this direction, and that's because on position number 2, I'm having what? Methyl, and on position number 2, I'm having what? Chlorine. So that's basically I'm going to consider it. So now let's go ahead and name it. This is going to be 2. Now look at this. This is another thing I need to consider. Between the substituents, which one is going to come first? you have to consider chlorine, because C, according to alphabetical order, C comes before M, right? So we're going to have 2 chloro, right? 2 chloro, then again 2 methyl, then this is going to be butane. 2 chloro, 2 methyl, butane. That's going to be the answer. Now let's go ahead and name another compound. You look at this compound here, right? You notice that we have an attachment at this point, right? And at the same time, an attachment at this point. But one thing I want you guys to understand is that this can actually be written. You can actually write this compound here. Everything that you're seeing here, you can write it and expand the chain in such a way that we're going to have 2 carbon, right? These 2 carbon. You're going to have hydrogen here, right? Hydrogen is here, right? Another hydrogen is here, another hydrogen is here, and then hydrogen is here. So this is basically C2H5. If you count it, C2, 2 carbon, 1, 2, and H5, 1, 2, 3, 4, 5, right? So this is basically ethyl, right? This is ethyl. So from there, it's connected to a carbon here, right? So if you consider the longest carbon atom, this is going to be the longest carbon atom. We're going to have carbon here, and then we're going to have CH2 here, right? Then followed by double bond CH2, right? So this is, I've actually write all this compound, I've write it into what you are seeing here. So what I'm going to do now is actually to go ahead and number forward and backward, right? I'm going to number from this side. That's going to be 1, 2, 3, and 4, right? So backward, I'm going to have 1, 2, 3, and 4. So if I'm considering the backward, the double bond falls on carbon number 3 and 4. But if I'm considering the forward, this side, the double bond falls under carbon number 1 and 2. So I'm going to pick the smallest one, which is actually 1 and 2. So what is the longest carbon atom here? It's actually 4, right? So and 4 simply represents but. That's what we're going to have. Then since on position 1, we're going to have put 1 in. That's what we're going to have. Then that's basically the bond and the position, right? And the carbon atom. The carbon atom is what is 4. That's how we have it to be put. The position of double bond is what is 1. Then since the double bond, we're going to end it with in. Put 1 in. Then look at this. Since I'm considering this side, I'm having 1 and 2 here. Then I'm having an attachment on carbon number 2, right? Then I don't have any other attachment. So this is going to be 2 methyl, right? Then boots 1 in. 2 methyl, boots 1 in. Or you simply say 2 methyl, 1 butene. So let's take a look at this compound that we have. Now, if you look at this very well, we are having double bond here, right? But we just have to consider the longest carbon atom first. So we're going to have 1, 2, 3, 4, and 5, right? 4 and 5 at the same time. So I just have to take one of it as a substituent. So numbering backward, now I'm going to have 1, 2, 3, 4, 5, right? So then I need to check if there is presence of double bond, either it's double bond or triple bond. Then I'm going to check their position. Then I'm going to check for substituents, right? Then at the same time, the position. So double bond come first. So here we look at this area. The double bond form between carbon number 2 and carbon number 3. If I'm numbering forward, but if I'm numbering for backward, the double bond falls between carbon number 3 and carbon number 4. So I'll prefer carbon number 2 and carbon number 3, right? So in that case, since I'm having 5 carbon atoms, 5 carbon atoms simply represent pent, right? This is going to be pent. Then the position of double bond is on carbon number 2. I'm going to have pent 2 in, right? Sorry, pent 2 in. That's what I'm going to have first. So pent 2 in. Then at the same time, I'm going to check for the substituent. The substituent is on position number 4, since I'm considering numbering forward. So the double bond is on position number 4. So I'm going to go ahead and pick position number 4. So that's going to be 4 methyl, right? 4 methyl or 4 methyl pent 2 in. That's basically the name. Now let's take a look at this compound that we have here, right? So if you look at this very well, we are actually having a special type of bond here, which is actually the triple bond, right? So we check for the bond according to Doma rule, check for the bond and the rule, right? Then the substituent and the position. Sorry, bond and position, substituent and also position. Keep that in mind. So let's check the longest carbon atom here. And if you count the longest carbon atom here, is actually 1, 2, 3, 4, 5, right? So this is basically 5, and 5 simply represent pent, right? That's pent. That's 5 carbon atom. Then if you look at this, we are numbering forward 1, 2, 3, 4, and 5. If I'm numbering forward, is on position 3 on carbon number 3. That's double bond is on carbon number 3. And if I'm numbering backward, 1, 2, 3, 4, and 5 is on position 2. The double bond is on the triple bond is on position 2. So between 2 and 3, which one am I going to consider? I'm going to consider 2 because it is the lowest. So I'm considering numbering backward here. So this is going to be pent 2 iron because we are having triple bond. Or you simply say 2 pentyne. That's going to be the name, right? Now let's go ahead and name another compound. Now let's take a look at this compound. So let's check for the longest carbon atom. This is going to be 1, 2, 3. We don't need that. 1, 2, 3, 4, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So let's consider this straight chain form, right? So we're going to number forward and backward. We're going to have 1, 2, 3, 4, 5, 6, 7. And backward 1, 2, 3, 4, 5, 6, 7. So if you go ahead and number forward, the triple bond falls between 4 and 5, right? 4 and 5. That's actually where the triple bond falls. And if you number backward, the triple bond falls between carbon 3 and 4. So we prefer carbon 3 because it's actually the lowest compared to carbon 4, right? So in that case, since I'm having 7 carbon atom, and 7 carbon atom is basically 8. So I'm going to have 8 here. 8. Then I'm having triple bond on position 3. 3 iron. That's what I'm going to have. 3 iron. Now, since I'm considering numbering backward, because it's actually it's conferred the lowest position on this triple bond. So that's what I'm going to have my attachment on carbon number 3, on carbon number 2, and at the same time 6. So I'm going to have 2, 6, right? Then this is basically dimethyl F3 in. That's basically 2, 6, right? Dimethyl F3 ion. That's basically the name. Now let's go ahead and name another compound. Now take a look at this compound that we have here. If you look at this, we are having 2 double bond, right? One at this point and the other one at this point. That's the double bond that we are having. So what I'm going to do now is actually to go ahead and number forward and backward and check for the I'm going to check for the longest carbon to carbon chain. Now counting from here, I'm going to have 1, 2, 3, 4, 5, 6. If I'm counting like this, I'm going to have the longest carbon atom is actually carbon chain is actually 6, but I don't count this particular double bond here. So I have to start from here. Let me just start from here. But I'm start from here, I'm going to have 1, 2, 3, 4, 5, 6, and that's also 6 as well. So in that case, if I number forward and backward, I'm going to have 1, 2, right? This is going to be 3, 4, 5, and 6. And if I number backward, I'm going to have 1, 2, 3. This is going to be 4, 5, and 6, right? So in that case, what does it mean? I'm going to consider this side because I'm having my double bond on position 1, and at the same time I'm having another double bond on position 3, right? Which makes it the lowest possible position that we can have. Then if I'm considering that, that's that everything here is going to be an attachment. Everything you're seeing here is an attachment, right? Because this compound is actually a branch chain, let's say a branch hydrocarbon, not straight chain hydrocarbon. That's a branch chain hydrocarbon. So in that case, since I'm having 6 carbon atom, I'm going to have it to be 6 carbon atom is basically X, right? X. And I'm having 2 double bond. One is going to be X. Look at this. On position 1, 1, comma. On position 3, I'm having another bond. That's going to be 1, 3, then diene. Why? Because I'm having 2 double bond on different position, right? And that's going to be X1, 3, diene. Now from there, we have an attachment here on carbon number 3. If you're considering numbering forward like this, going from this side up to this side, right? We're having it on carbon number 3. But if you consider going from this side to this side, we're having what on carbon number 4. So the one to prefer here is actually, since we go for the lowest possible position for the double bond, that's that forward numbering is actually what we are going to consider. And that case, attachment is on carbon number 3, which means everything here, which is actually 2 carbon atom, it's actually ethyl. right? That's basically ethyl. And what you are seeing here is methyl, right? And if you look at this very well, this is methyl. And according to alphabetical order, E comes before M, right? So in that case, I'm going to consider E first, and that's going to be 3, right? 3-ethyl or ethyl. Then we are having on position 4, that's another methyl. Then 4-methyl, right? X 1,3 diene. That's basically the name. Now take a look at this compound that we have here, right? If you look at this very well, we are having double bond and triple bond at the same time. And as far as priority is concerned, we are going to give the priority to the one of triple bond because it is highly reactive compared to the one of double bond, right? So we're having double bond here, triple bond here. That basically means this triple bond and double bond are going to come out as prefix. But the one that will actually bear the family for this kind of compound is going to be the triple bond. So that's that I'm going to consider numbering from this side, right? Because if I number forward and backward, I'm going to have 1, 2, 3, 4, 5, 6, and 7. And backward number, I'm going to have 1, 2, 3, 4, 5, 6, and 7. So numbering from this backward side, I'm going to have this guy to the triple bond to be on position 2, and the double bond to be on position 5, right? So in that case, I'm having 7 carbon atom, which is basically eth, right? And there is no attachment, it is basically eth. Then in this case, I'm going to have eth 5 in. And why am I considering 5? That's because I need to give the triple bond the lowest possible number, which is 2. So if I'm numbering from this side, that basically means the triple bond is going to be on carbon number 2 and the double bond is going to be on carbon number 5. So we're going to have eth5 in, then we're going to have 2 ion. That's going to be the name, right? That's going to be the name. Now let's go ahead and name another compound. Now let's take a look at this question. We are having double bond here, right? Then let's go ahead and check for the longest carbon atom. By numbering forward and backward, we're going to have 1, 2, 3, 4, 5, 6. And backward, we're going to have 1, 2, 3, 4, 5, 6. This indicates that whether we number forward and backward, the double bond falls on position 3 and 4, while the attachment as well falls on position 3 and 4. So in that case, we're going to have, since 6 is the longest carbon atom here, and that's going to represent X, right? The position of double bond is going to be 3 in. Then we're going to have X3 in, and the attachment here is on position 3 and 4. So we're going to have 3, 4, right? Dimethyl X3 in. 3, 4, dimethyl X3 in. Dimethyl says that we are having 2 methyl group, dimethyl, right? And then X3 in. We are having on position 3, we are having the double bond, which is 3 in. So that's going to be the name. Now let's go ahead and name another compound. Let's take a look at this compound that we have here, right? It's a little bit long, right? And it's very, very simple. Now look at this. Let's consider the longest carbon atom by consider these straight chain forms. We're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. Just that if you count in the straight chain form, we're going to have the carbon to go to be 9 carbon. Now let's say we consider this side from here. 1, 2, 3, 4, 5, 6, 7. It is not long enough. Then 1, 2, 3, 4, 5, 6, 7, 8, 9. Counting from this side here as well up to this side, it is 9, right? And we cannot just count like that at the same time, right? So let's consider this side as well. 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you consider this side, it's also what? 9 as well, right? So, and again, that's that whichever way we try to count, even including this side, 1, 2, 3, 4, 5, 6, 7, 8, 9. Whichever way we try to count, the carbon atom here is actually what? 9, right? So I prefer counting from this side. 1, 2, 3, 4, 5, 6, 7, 8, 9. And let's go backward. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now look at this. It's very, very simple. we have a lot of attachments here, because everything here, there's no there's no double bond, or let me simply say triple bond here. Everything is single bond or true between the carbon to carbon atom. So, and 9 is basically nonane, right? Let me just put it here, nonane. So with no stress, that's nonane. That's all you have. Now, if you look at this, if you consider this site, we are having on position 3, we are having an attachment. Everything you are seeing here is an attachment, and it is basically ethyl group. That's ethyl. Now, everything you are seeing here on carbon number 6, we are having another attachment, right? And it is basically what? Propyl, right? And then on carbon number 8, we are having 2 methyl group attached to this carbon. On carbon number 8, 2 methyl group, right? So that's basically what we have. So you have methyl, ethyl, and also what? And also propyl. On what position? We have position 3 plus we are having position 6 plus position 8. That's what we have. So if you number forward like this, these are the position that we have. Now let's sum it up. If we sum it up, this is basically 17, right? We will sum it up. Now counting backward, we are having on position 2, right? Plus we are having on position, what again? 4, right? Then plus again, we are having on position 7, because on position 2, if you count backward like this, if you follow this direction, on position 2, we are having what? 2 methyl group. That is basically on carbon number 2. Then on carbon number 4, which is this, we are having what? A propyl group, right? Which is basically this one that you're seeing here. Then on position number 7 here, we are having another what? Another attachment, which is ethyl, as you can see, right? So in that case, that's 7. So now let's sum it up. Let's see what we're going to have. And in this case, this is basically 7 plus 6, and that's what? 13, right? So in that case, do you know what we are going to consider? We're going to consider numbering backward. Why? Because if you sum all the position up, it's actually accumulates to the lowest possible number. Instead of 17, we pick what? 13, right? So in that case, what am I going to have? That's just on position number 2. I'm going to have, you know, this is M, methyl, and this is E, ethyl. Ethyl must come first before methyl according to alphabetical order, right? So in that case, we're going to have on position 7, we're going to have 7 ethyl, right? 7 ethyl, then followed by M comes before P. This is 3 carbon atom. 1, 2, 3. That is propyl, right? Prop is basically 3 carbon. Then since this belongs to alkyl group, we call it propyl. So in that case, 7 ethyl. Then on position number 2, we're going to have 2, 2, right? Dimethyl, right? Then followed by what? On position number 6, we're going to have, on position number 4 rather, we're going to have 4 propyl nonane. That's basically the name, right? 7 ethyl on position number 7. E comes for 7 ethyl, 2, 2 dimethyl. Methyl comes followed by methyl. Then 4 propyl. On position number 4, we have what? Propyl nonane. That's basically the name. Now let's go ahead and name one more compound. Now let's take a look at this question that we have here, right? It's quite a little bit different from the one that we have been naming due to the position, due to the attachment, and this attachment that you are seeing here. So what I'm going to say now is that kindly pause this video and try to name it out. You understand? Once you name it, drop your answer in the comment box below. I'll be there to reply you, and at the same time I'm going to do the correction in just a moment, but just go ahead and try it first. Now let's number forward and backward. So here we're going to have 1, 2, 3, 4, 5, 6, and 7. Right? That's actually the longest carbon atom. But if you choose to count like this, 1, 2, 3, 4, 5, 6 is the 6. 1, 2, 3, 4, 5, 6 is the 6. So 7 is the longest carbon atom. Then let's go ahead and number this guy here as your backward. 1, 2, 3, 4, 5, 6, 7. And again, what is the importance of numbering forward and backward? The importance is just to check for the lowest possible number for either double bond, triple bond, or a substituent. That's basically the essence of numbering forward and backward. Do you get it now? Now let's go ahead and analyze the position. On carbon number 3, if you number forward following this order, on carbon number 3 we have a methyl group, right? And on carbon number 4 we have another attachment here that you're seeing here. Then if you follow this side, we are having methyl group on carbon. We are having these attachments first on carbon number 4, and we are having this guy here on carbon number 5. So we are going to choose forward Why? Because it gives lowest possible number, right? Lowest possible position, right? Between 3 and 4. And then if you choose backward like this, it is between 4 and 5. So agree with me, 7 is much more lower than what? Than 9. So we're going to follow 7, which is what? Backward, or forward rather. So in that case, we are having 3 here. This is going to be 3 methyl, right? 3 methyl. Now, one thing I want you to know is that you see this attachment that you're seeing here is a kind of complex substituent. And when I get to in a separate video, I'm going to make a IUPAC naming of those complex attachments, and I'm going to explain it in details. We have isopropyl, we have isobutyl. I'm going to explain everything step by step so that I can get it. But at first, what we are saying here is 1, 2, 3, right? Since the carbon atom, let me say, since the bond is on this is at the middle part, at the middle of the carbon, because you can't see this 1, 2, and 3, and the bond is at the middle of this carbon here. That is basically isopropyl. 3 carbon atom is what is prop, but since the bonds are the middle, not at the beginning. For example, you're having CH3, CH2, and then you're having CH, let me say CH2, then you're having a bond here. This is normal propyl, because the bond is what is at the first, like at the first carbon, is on the first carbon. But since the bond is on the what, on the second carbon, as this case in B, that is basically isopropyl, right? That's isopropyl. So we're going to have 3 methyl, then we're going to have 4 isopropyl, right? Then followed by 7 carbon atom is what is basically heptane, right? That's basically what we're going to have: 3 methyl, 4 isopropyl, heptane. That's just the name. It's very, very simple. Now let's go ahead and write out the final question, right? So that question, you're going to solve it yourself, and you're going to let me just say, drop the answer in the comment box below, right? And let me just give you the question so that I can actually so quickly solve it and then drop your answer. So in that case, let's say we have CH3, right, followed by CH2, right, then followed by CH3, right, then we're going to have CH2, right, we're going to have CH3, right, then followed by, let me see, we have CH3 here. So go ahead and name this compound and let me know your answer in the comments box below. Then another one, let me just give you this guy here, skeletal structure. I'm going to name the skeletal structure in a separate video, right? So go ahead and name this guy here as well, right? Go ahead and name this guy here. Drop your answer in the comment box below. Then another one, the third question, I'm going to give you this guy. So make sure you go ahead and then drop your answer in the comment box below. I'll be there to reply you guys. So just go ahead. These are under skeletal structure. These are under skeletal structure. So go ahead and name them, and make sure you drop your answer in the comment box below. So that's just about this video. So I'm going to release the second part of this video, because I'm going to make them like about this IUPAC. I've actually divided them into 6 to 7 videos. So this is just the part 1. So wait for the part 2, the second part of the video. So if you enjoy it, don't forget to like, share, and subscribe. Thanks for watching.